Hi. Hello, good morning. Now we are going to see a lecture based on a professional electric. Since I think you guys have adopted this electronic packaging, which is a professional subject related with packaging. Since all our electronic students, they should explore how a system packaging is going to happen, and also a device package is going to happen. And all these are related with semiconductor packaging also. So we enter into this introductory lecture. This introductory lecture is based on microsystems and micro technologies, and these technologies are going to happen, or it is happening in this era. Once a device has been fabricated, maybe you can take a VLSI chip, or you can take any IC. It may be a digital or it may be an analog. And how these chips are to be packed. The first concern, how it is going to be protected from the electronic interference and from the external environment. So we need to think about in such a way how system packaging is going to happen, how MEMS packaging is going to happen, and also all the semiconductor devices, how it is packed in a perfect way whereby it is suitable for all the electrical signals to pick up and all the sensors, how it is going to be packed and it is stable to the mechanical counter effects, mechanical stability, how it is going to be established. So this introductory will give you an idea why we need packaging. So it's a very simple concept. So many of you wonder like why we need to do these packaging. So what is the effect of this? Just like that we can cover and outer covering alone it can happen in a particular design. But that is not the apt. Here we need to explore a lot what type of materials we are suitably adopting. That is also a very important concept. So let me start. Good morning. Welcome to the next session where it deals with the materials used in packaging. So in the previous sessions, we had the hierarchical levels, functionality, and how these packaging techniques have been used for making different ICs and how it is involved in device packaging. MEMS packaging also we have discussed. Now, shall we start the material concepts? Because material science plays a vital role in the design of our IC. So now coming for the packaging unit, so I think this slide is visible, right? Materials for microelectronic packaging, which deals with the properties. Why we should know about the properties? First, let me tell properties. So very important for signal electrical property, thermoelectrical property is important. Mechanical property is important. Stability, encapsulation is required. For that encapsulation, what type of sealing is required? Sealing is related with how we can tightly pack your IC so that there won't be any loose connections further. And if that sensor is interfaced onto a board where it can be a chip on board, then how this unit is going to function and give its entire efficiency in such a way the conversion of signal from one end to the other end is going to happen. So all these are possible by means of choosing a proper material. Proper material in a sense that satisfies almost electrical, thermal, mechanical. Thermomechanical is also very important, and chemical is having a property for design of sensor. So these chemical properties also we need to analyze. So electronic packaging, it deals with various materials. First, let us go with the ceramic type of material. Ceramics. What do you mean by ceramic? Whether a compound semiconductor or it can be with alumina. Alumina is nothing, aluminium. It is oxidized, Al2O3. And aluminium nitride, AIN. Nitride is a compound here. And carbide is also mixed with silicon. It forms silicon carbide in an equal ratio, or it can be with a different proportion also you can make. So these things are going to be alloys. So ceramics, it possesses a very good electrical insulation, high thermal conductivity, chemically stable, and it possesses a hermetic. Hermetic is nothing, it's a tight seal. Used in substrates, high power modules, RF devices, where a common ceramic material we can take and analyze the heat also, the performance would be quite good. When a comparison chart has been established, ceramic is going to have a very good property of excellent insulation, thermal conductivity, stability, and also sealing. Cost-wise, it is higher. So this is one of the hindrances which we can see here, because plastics and metals are going to be lower cost. And suitability is also excellent. And we need to go with a compromise here. We need to compromise the cost. Otherwise, excellence cannot be achieved. So ceramic plays a vital role in today's life. Low temperature profile and as well as high temperature, that is your HDCC and LDCC components. So they are used in almost all our designs. And when you take in terms of electronic packaging, alumina will be a very good material which is going to be used for substrate, and nitride combined with aluminium, it is used for high thermal conductivity, thermocouples, temperature sensors. That would be quite example for this, where heat dissipation concern has been taken care. And silicon nitride with a high mechanical strength, thermal shock resistance, it is used for the structural components. In silicon carbide, if you take excellent thermal conductivity, hardness, everything is going to be achieved. And glass ceramic, where it is a combination of glass, a transition temperature of a glass material which is superimposed with a ceramic material which possesses a low dielectric constant, and substrate which is used for thermal hermetic sealing counterpart. And electrical property, an excellent electrical insulation, low dielectric constant, stable dielectric properties. So these are the achievements or electrical properties, how it is achieved in terms of heat, stability, and tough conditions also. Here, different types of designs you can make, and thermal properties are very high with thermal conductivity, low coefficient of temperature, with thermal expansion and thermal stability. Above 150 degrees Celsius also, it's going to retain its shape, strength, and function. Hence, obviously, ceramic is used. Mechanical property, if you take high strength, hardness, and good fracture toughness, compressive strength. So compressive strength has to be analyzed whenever a compound is going to be supported or it is going to be mounted on top of a board. Maybe like a PCB board also you can. And chemical properties are related with inertness and corrosion resistance. The hermetic sealing capability, it is for the airtight seals which you can accomplish by means of any adhesive or it can be with a tape. Applications: substrates, hermetic package, high frequency devices, power electronics, LED packaging, microwave and radar systems. If you take the challenges, cost, brittleness, processing complexity, and thermal expansion, if these challenges are going to be overcome, then ceramic is going to be a unique material which can be used for packaging unit. So these are the advantages it is possessed, and also alumina is going to be the second material. Here alumina in the form of oxide, where oxidation is going to be the fabrication of aluminium oxide based ceramic, and here it is stronger. The ductile strength is also very good. Electrical insulating property are better, and thermal conductivity is very acceptable in the range. The sapphire is a single crystal form of alumina. Sapphire is a component which is used in a lot of applications, which is used in high power circuits and flexural strength. is very high, and demerits relatively high thermal expansion, and it's intermediate between silicon and copper. Moderately high dielectric constant. And beryllium, if you take beryllium oxide and beryllium, they are superior to aluminium with respect to thermal properties. In the form of a powder, it is very toxic, so it's very crucial to handle these type of materials. So chemical properties has to be understood. So that is a unique thing which you need to go. Cost is higher, about 10 times costly than aluminum. So nobody is going to prefer it. Then why it is used? So conductivity, if you take 10 times higher, and if its thermal expansion is comparable to aluminum, the dielectric constant is also lower than aluminum. If you take aluminum nitride in comparison with beryllium oxide, the toxicity level we need to analyze. How much toxic? Thermal conductivity is slightly better, and value of thermal conductivity of pure aluminium nitride, it approaches to aluminium. Aluminium is a very cheaper component which is available as a metal, and this alumina can be made in terms of alloy like aluminium nitride, aluminium oxide. So it is preferred compared to beryllium oxide, where beryllium is going to be a costly material. In surface roughness, if you compare, and reliability concern also if you take. So the exposure to humidity at high temperature, and aluminium nitride is going to react with alkaline solutions to use in cleaning and plating operations. So that is electroplating operations which are used in the fabrication units. So aluminium is a very cheaper component, so it can form alloys with oxide as well as nitrides, and further it can be used for the packaging unit. So that is the concept. And when you compare with beryllium oxide and aluminium nitride or aluminium oxide, the preferable component it can be aluminium nitride and oxide only. So that is the conclusion which we can make. And if you go with the carbide, so nowadays silicon carbide is going to be a very cheap component, and it possesses a lot of interesting properties. Polycrystalline semiconducting phase is established. It's not a very good insulator, even though it is used to increase with respect to the resistivity where it is possessed by beryllium oxide. And silicon carbide with small amount of beryllium oxide, which we call it as a HITA ceramic. It's a very unique distinction which we can make. Kita is used in a lot of applications. It's an advanced material also, and it has a thermal conductivity which is twice that of silicon carbide. Even though silicon carbide is going to have a very good thermal conductivity property, further twice that of it is possessed by Kita. So this uniqueness in temperature conductivity part plays a vital role in lot of temperature sensors. So HITA is a very good component which can be taught for future investigations and also for lot of sensor designs. Boron nitride, if you take, it exhibits three allotropic forms. It can be with a H and C type. H type is a soft graphite in a hexagonal part, and C type is a hard with a cubic form. So we know what is cubic with the six phases. The properties of hexagonal and isotropic feature is going to have where the etching is not uniform in all the directions. One particular direction, it can have a sharp cuts. That is anisotropic. And if it is a soft, weak, and susceptible, and it is hard to metallize, and it also possesses a low dielectric constant with a CTE, temperature coefficient of expansion. And glass, when it is combined with ceramic, it can be used as a alumina material. The crystalline phase is going to possess a high melting point. Dielectric constant is around 5 and possess a lower thermal conductivity, and conductivity is going to be very less. They have a good thermal match with silicon and thereby are very compatible with gold and metal. With copper, metallization is possible, and materials which can be used, metals copper, aluminium, gold, silver, nickel, tin, beryllium. So they possess high electrical and thermal conductivity. And also if you see a mechanical support, electromagnetic shield. Applications of lead frames in chip designs and all, you can see the leads. The frames of that can be made with this metal because metal is a suitable conductor. Connectors, heat sinks, solder bumps. So these solder bumps can vary in different shapes. Can be a radial, circular, spherical. So different forms it is available. And in form of a dot, if you take a circular dot is also a solder. And enclosures can be made with respect to that. A summary table if you possess a metal, if you take copper, aluminium, and copper alloy is a moderate material which can be used for the housing, the packages, and hermetic sealing. And also if you take gold, nickel, and steel, so they also have a structural property and also the enclosure part. So it is corrosion resistant. And different parameters have been analyzed. All these are some of the electrical conductivity, thermal conductivity, CTE, density, and what is the typical use of each and every parameter. So this will give you a summary chart which will decide which material you can have. Thank you. So thank you for your patience in understanding the material property. So this gave you a simple guideline to fetch a typical material and use that material for packaging.